Okay, here is my lesson on how the sun's energy causes seasons here on Earth. I know from personal experience that most of my students have the common misconception that it has to do with the fact that the Earth is closer to the sun during the summer months and further away during the winter months, which causes it to be hotter in the summer and colder in the winter. So this demonstration is meant to illustrate how it doesn't have anything to do with the distance that we are from the sun, but rather the tilt of the earth and how it affects the amount of direct sunlight that we get during the different seasons. So the setup that we have here is we have a board that has two aquarium thermometers mounted to it, and the thermometers, when they're exposed to heat, they change colors as the temperature goes up, so we should be able to see the change in temperature. And you can see right now that in my room it's about 68 degrees Fahrenheit, or approximately 20 degrees Celsius. And I've mounted one at the top of the board to kind of show what it might be like in the opposite hemisphere, and then another one down here at the bottom. And you can see right now, with no direct light hitting, even though this thermometer is upside down, it's approximately the same temperature at both of our hemispheres, about 68 degrees Fahrenheit. So in this model, we're going to utilize if I can get it here so we can see it, just an aquarium light that you would use for a reptile tank to represent the sun. And to start with, we're just going to hold it so that it is kind of hitting in the middle of the board here. Let's see if I can get back far enough so that we can see it. And so we've got not a whole lot of direct sunlight hitting at either one of the hemispheres, and from my vantage point here, even though the light's only been shining there for a little bit, both the northern and the southern hemisphere that doesn't get a whole lot of direct sunlight, both of the temperatures have increased to 71 degrees Fahrenheit, pretty equal. It's going up a little bit higher in the northern one, but still not drastically different. Maybe I'm holding my sun at a little bit different angle here. But if we get a little bit closer here, hopefully, if I take the light away, you can see that in the northern hemisphere, the temperature is 75 degrees. And down here in the southern hemisphere, we're close. It's gone up a little bit. It's sitting at 71 degrees. But if I give this southern part more direct sunlight and aim it right where the direct sunlight hitting down in the southern portion of our model, then we start to see the temperature increase, even though the sun is not any closer than it was to start with. Down where we've got direct sunlight, the temperature is all the way up to 82 degrees Fahrenheit, and up in the southern or the northern part, it's fallen down to 71 degrees and looks like it's going down even further. Now we're up to, with direct sunlight, up to 86 degrees in the southern hemisphere, and we're still sitting at about 71, so kind of maintaining. And we're even approaching that 90 degree range down in the southern part with direct sunlight. So if we look here at our color thermometer, you can see that we're sitting at 86 down here in this northern part that got the direct sunlight, even though that's upside down. Whereas up here in the northern part, we're falling down to that 68 that we started at. even though it's sitting there at 72. But if we get direct sunlight hitting up here, we'll see the opposite effect. And indeed, even though the sun's no closer, we're holding it at an equal distance. The temperature is going up here in the south because of the direct sunlight. And then in the north, we're not getting a whole lot of sunlight, and the temperature is starting to decrease there. And so, yeah, there's some distance difference. And probably if we just held angles, I think we'd get a little bit of different effect here. But let's see if we can see the temperature change. So now in the north, I get us to focus. We've got 82 degrees, maybe 80. Whereas in the south where we had indirect light, it's gone down to 70, almost 75, down to almost 71. So you can see that there is temperature difference just by the amount of direct light that you're getting in the area, which causes our seasons.